Okay, so in this video, we'll be solving an exercise about languages and in particular language operations and sort of properties. So we have this finite language here, L1, AB squared, and we want to know how many strings of like 0, 1, and 2 are in L1 star. So first of all, let's just remind ourselves what is L1 star. L1 star is the infinite union starting from 0 of language exponents of L1. So L1 power I for every I starting from 0 and then unioning all those things. So then what this would give me is L1 power 0 union L1 power 1 union L1 power 2 and so on. So if I represent this more explicitly, remember the convention is that any language power 0 is the language containing the empty string. Then union L1 power 1, well, that's just L1, right? So that's A, AB, and then AB square. I'll write that for compactness. Union L1 square. What's L1 square? Well, it's L1 concatenated with itself, right? So copy, paste, paste, okay, and so on, right? So this is what L1 star is. Okay, so now what we're being asked is how many strings of length 0, 1, and 2 are there in L1 star? So, I could, in theory, keep unrolling this and try to compute every single string in L1 star and then find some kind of closed form for it. But it's not actually necessary, right? Because all I need is I need to find the strings that are of length at most 2. So the trick there is to identify the fact that as you're concatenating more and more languages, the sort of the minimum length of your concatenating string is going to get bigger and bigger, right? So here, when it's L1 not, the minimum length of the concatenating string is 0. Here it's 1. Here it's going to be 2, right? The minimum length is 2. So I'm going to have A concatenate with A. So the shortest possible string that I can create from L1 square is going to be size 2. What about L1 cube? Well, L1 cube, I'm going to have this thing 3 times. And then the shortest possible string I can create from that sort of language concatenation is A concatenate with A concatenate with A. So that would be A cubed, which is of like 3, and that's already bigger than the sort of um, upper bound I kind of care for or care about. So that means that I can actually stop doing this computation at this point, right? Okay, so that's a nice first observation so that I don't have to sort of find a closed form and sort of try to think more carefully about where the strings of length 0, 1, and 2 are. Instead, I can just stick them in a set here. So I'll have, so let's see, strings of length at most 2. So I'm going to have the empty string, of course. So the empty string, let me use green. The empty string from here, then A from here, AB from here, AB square, so that's AB, so that's a length 4, so that's above my upper bound, so I don't care about that. Then here, I actually do have to do the operation for at least in part, right? So A and A, that's going to give me A square. Then A here is also going to concatenate with AB and AB square, but those are strings of length 2 and 4. So if I'm concatenating them with a string of length 1, then I'm going to get strings of length 3 and 5. So I don't even care what the result is. So I can just skip that. And then here I have a string of length 2. So a string of length 2 with concatenated with a string of length 1, 2, or 4, that's definitely greater than the length of that is going to be greater than 2. So I also don't have to compute it. And then AB square, well, this is of length 4 already. So whatever I do, I'm not going to have something that's in the end of length at most 2. So I don't have to compute it either. Why am I showing you this trick? Because for instance, if this is like a true false or an MCQ, instead of wasting your time doing all the computation, you can maybe just identify this and then be like, okay, I don't need to do this small operation and now I get my answer, right? So the only thing I actually had to compute was this A concatenate with A, which gives me A squared. So then I have some other stuff that I don't care about, which I don't care about. And so I take this A squared and put it in here. And so then in total, I have 4 strings of length at most 2. I have one of length 0, 2, or sorry, 1 of length 1, and then 2 of length 2. Okay, and then that's how you would solve this exercise.